All right, let's talk about something that's in almost every single one of our homes, something we completely take for granted. But, a new breakthrough could totally change it, making it safer, way more efficient, and so much better for the planet. We're talking about the future of how we keep things cool.
So just think for a second about your refrigerator or your air conditioner. They kind of work like magic, right? They literally make coldness out of thin air. But what if I told you that this everyday magic has a pretty big hidden cost? A dark side that's actually having a huge impact on climate change. And this really gets right to the heart of the problem. On one side, what we want is super simple. We want our food to stay cold. But on the other side, what we get is this really nasty byproduct, incredibly powerful greenhouse gases. For decades, that's just been the deal, an unavoidable trade-off.
So let's really dig into the specifics here, because once you understand the problem, you'll see why this new solution we're about to talk about is so exciting.
Okay, so most cooling systems today, your fridge, your AC, they all run on chemicals called hydrofluorocarbons, or HFCs for short. And these aren't just your average greenhouse gases. They are shockingly powerful. Some of them are thousands of times more potent than carbon dioxide. The problem got so bad that countries all over the world signed something called the Kigali Amendment, which is a global promise to cut HFC use by 80%. That's a huge target, and it means the race is seriously on to find a replacement. And this quote from engineer Drew Lilly just nails how big of a challenge this is. It's a massive technological puzzle. Finding one thing that checks all the boxes, it makes stuff cold, it's efficient, it's safe, and it's good for the environment, that's been basically impossible. Until, maybe, now?
So let's meet the new kid on the block. It's a completely new method called ionocaloric cooling. And the big idea behind it is actually based on a principle you've probably seen happen every single winter.
Yeah, this really breaks down a complicated idea into something simple. I mean, think about what happens when a truck throws salt on an icy road. The salt itself isn't hot, right? But it forces the ice to melt. And that process, that physical change from solid to liquid, actually sucks in heat from the air and the road around it. Ionocaloric cooling is just a really clever, high-tech way of doing that same exact thing on demand. Okay, so how do you take that simple idea and turn it into something like a working refrigerator? Well, let's see how it all fits together into a complete cooling cycle.
All right, let's just walk through this cycle. First, you start with a special kind of liquid solvent. Then, you add a type of salt. Now here's the cool part. You apply a tiny bit of electricity, just a little current, and that moves the salt's ions around, forcing the solvent to melt. And just like the ice on the road, that melting process absorbs a ton of heat, making everything around it get super cold. Then, you just reverse the current, and it releases all that heat somewhere else, like out the back of your fridge. It's this clean, elegant, continuous loop.
Now, all of this sounds great on paper, but does it actually work? And could it really go head-to-head with the technology we've been perfecting for over 100 years? I mean, is this really a revolution in the making? Let's take a look at the evidence. And the evidence is, well, it's pretty stunning. In their very first experiments, the researchers got a temperature drop of 25 degrees Celsius. That is a huge cooling effect. And get this, they did it with less than 1 volt of electricity. That points to a system that isn't just powerful, but could be way more energy efficient than anything we use today.
And this really hits on the most important point. According to researcher Ravi Prasher, any new cooling technology has to win on 3 different fronts: its environmental impact, its energy efficiency, and its cost. And right out of the gate, ionocaloric cooling was looking really promising on all 3.
I mean, this table just lays it all out, doesn't it? With current tech, you've got a high global warming potential. With ionocaloric, it's 0. Today's tech is efficient, sure, but this new method could be even better. And your key ingredient goes from being a harmful greenhouse gas to a simple salt and a solvent. It's just a night and day difference.
But hang on a second, because it gets even wilder. Remember how that last slide said negative GWP? How was that even possible? Well, it turns out the solvent they're using can actually be made from carbon dioxide that's been captured from the atmosphere. So the system wouldn't just be carbon neutral, it could be carbon negative, actively helping to remove CO2 as part of its manufacturing process. That is a total game changer.
Of course, there's always a long road from a cool discovery in a lab to a real product you can buy. So what does the future actually look like for ionocaloric cooling? The progress on this has been incredibly fast. The first big paper came out in the journal Science in 2023. By 2025, they were already publishing new research on even better materials to make it more efficient. So the next big step, the final boss, is taking all this potential and actually engineering it to scale up for our homes and businesses.
And as Ravi Praksher says here, the basic science is solid. They've proved this totally new way of making things cold actually works. So the mission now is really shifting from scientific discovery to pure engineering, finding the right designs and materials to bring it into the real world.
And that leaves us with this incredible question. For the first time, maybe ever, we might not have to pick between having modern cooling and having a healthy planet. This new tech offers this amazing possibility of doing both at the same time. So the real question isn't if this will change our world, but just how soon it's going to happen.